Okay, you had your 7 minutes. Now I have my other, whatever, 20 minutes, and then you're free again. So one thing, okay, we talked IaaS, we talked about the motivations behind it and why we need it and all that kind of stuff. But I didn't really tell you how it looks like internally, right? So there are some principles that are kind of recurrent in all those infrastructures. But of course, the most dominant one that we'll be looking at is OpenStack, simply because it's open source, so you can actually look at it yourself. You can even run it yourself if you want. You want to have a rather punchy machine to do that, though. The other thing is, of course, that we have a hosted deployment of this one. And this falls in the private cloud category. So the idea is there that OpenStack is not a service per se, it's just the software. You need to run it on your own hardware. And then can offer it yourself to someone else. And we happen to have an OpenStack cluster at EEC down here, and they graciously offered us to use it for that course. So you guys can actually log in, play with this, get an understanding, and yeah, that's our free access basically. So OpenStack. So the idea is, what were the core components of a IaaS infrastructure as a service? What were the core components in addition to PaaS services? What does it need to provide? No? Speak up. Tuesday afternoon. Everyone is shy or sleepy.
I missed the question.
Sorry? You missed the question. The question was, what is the functionality that you would expect from an infrastructure as a service platform? What does it need to provide? In addition to PaaS, for example, right? So, so what are the features you need to, to build one yourself, if you like?
Routing.
Yep, cool.
Like general networking, access lists.
Yeah, the access list. Yeah, that's very good. Yes. Are you talking access list in terms of networking or more generally?
Like open ports, it's allowed in which blocks.
Yep. Cool. Yeah. So you're talking network style. Okay. Good. Of course.
We need some storage.
Storage, yep. Cool, what else? Can't be too hard now. They made the start. They made a good start. What else? Two more components? No? Yes? Perhaps? Well. Generally need some sort of processing, I suspect, and a bit of RAM as well, right? So those are so if you add those components into the mix, you kind of have hardware. If you virtualize this thing, you have infrastructure as a service. So that's the key idea. And we see that reflected in the OpenStack components. This is a bit of an older schematic. There's one or two modules missing, but it doesn't really matter because the core modules are provided here. And that's the key idea. So it's quite interesting to see how it's actually decomposed in practice. So at the core of the operation to some extent is Nova, which is basically the computing platform providing computational power and having the RAM attached to it. So that's where all the basically hardware is integrated, and basically all requests and processing is delegated to that part of the platform. Then we have a different module called Cinder, which is like the block storage. Block storage is like something like hard drives. That's where you basically are provisions 80 or 100 gigabytes and so on of data on that shared storage, which is associated with your computing instance sitting on Nova. And then the networking bit, yet another entity. It's just dealing with the virtual networking within the different units. So basically everything happens within that cluster, but you have the impression as if you have proper networking, as as we talked about in the last week. The very much same thing. In addition to those core components, those three components, we have an image service. What is that for?
Handling of the images of that you can start, like the operating systems, snapshots of setup.
That's right. So it's basically a stock installation of the set of operating systems you can pick from, right? So because one of the ideas is you want to be quick in bringing up that platform. You don't want to waste much time and installing operating system yourself, figuring out all of the drivers for different things and so on. because the emulated hardware environment, so basically the hardware architecture in OpenStack is kind of known and given, right? So that gives you an opportunity to have a stock image which is kind of ready for your use, right? So the only things that really change between those images will be the IP addresses, of course, that's part of the networking unit, and host names, things like that. But other than that, they're stock images that are kind of all the same, from which you at least start on off from. So another aspect that is also added is object storage. Does anyone know what that is for? Doesn't seem to be intuitive in the PC world. So most of the infrastructure as a service providers, particular Amazon, I think that was actually their first product, is to provide just a shared store for large data, right? So you can put like data sets or something like this of images or files or whatever else in there and share them easily between different machines. That's the key idea. Whereas block storage, that's the Cinder component, is traditionally just associated with one machine at a time, right? Of course, you can share by networking means if you hack it on the operating system side by providing, FTP or SSH access, but it's not generically shared amongst different instances. That's where the object storage comes in. So if you pair this whole thing up then with an identity service, of course, that manages the access to it, because you need to have quotas for what you can use, right? So you won't want to be you guys should be constrained in how much memory you want to use, in how much disk space you can use, and how many CPUs you can possibly allocate. So it needs to be managed somehow as well. It's yet another component. And then you integrate this whole thing via dashboard, so you can actually click on something and they would do stuff. So that's basically a main component of OpenStack. And so that's what we'll be dealing with. Under the hood, of course, there's way more happening, right? So in all those different components, particularly in controller mode, that links to different services and deals with the messaging between the component, has an image service that accesses the images that are provided and shares them. And then we have, in the computing area, we have things like a hypervisor, something we haven't talked about yet, and so on, and then a virtual network environment that has all the routers and switches and so on, all these different software components that are contained in there. We're not looking at any of those because that's not really relevant for us. We just look at the bigger picture. So that's just one overview of how they actually all are integrated. And the reason why I'm showing you this one is just to get an appreciation of the API aspects. So we have Horizon on the top left there, which is basically the dashboard that you guys will be dealing with, from which you start instantiating your instances and so on. And you see from there on, there's a lot of OpenStack specific API calls, right, to all the other units. So the whole system is basically tied up itself already by heaps of different API calls amongst the different components that we just highlighted. And there's a nice example, for example, between the Glance API and the Neutron server that provides networking. It actually relies on the EC2 API from Amazon Web Services. So you see actually a case where it's actually borrowing from Amazon some API to be compatible. So it's easier to deploy some functionality. But fundamentally, that's what it is. So you have different components, ideally running on different machines, right? So you have different machines managing those components that are then interacting just by API calls. Cool. All right. So we have one at Jörvik. You can run it yourself if you want. If you have a juicy machine, there's a DevStack project that basically allows you to have a kind of a turnkey solution that you can deploy immediately on your machine. But you need to have a juicy machine to do that. But I think for our purpose, particularly if you want to use it and explore it with a bit more multiple instances and so on, where you need a bit more juice, probably more sensible to use the NTNU one. And to do that, I asked you about 1 week ago that you can, if you could log into this service using your usual NTNU credentials. I didn't hear anything back on this in this respect, so I suspect everyone could log in. So just use your normal faded credentials and you'll be fine. There is, of course, documentation of how to access it, how to get stuff done, particularly with respect to the particular installation here, because some aspects have been localized, and the start guide is also linked here. But all the links that are relevant are actually in the wiki. If you have seen already, there's a service section services section right now that points to OpenStack references. So if you need it, one note in advance: if you're working outside of NTNU, you need to connect to the VPN first, right? So you guys know that NTNU offers VPN services. Yes? No? Perhaps? No? Good. If not, have a look at INSEA and type VPN in there, and they actually get a quite good guide of how to get it done. I think I put a link to that relevant page into the wiki as well. But it's only relevant, again, if you're outside of the NTNU network, because otherwise you won't be able to access OpenStack instances. And that's a very good idea. Any guesses why? Did anyone run an unsecured Ubuntu instance or the like on AWS before? You probably have like 5 minutes under someone else in your machine, right? So there's so much traffic, and because you're exposed to the public net immediately, there's no limits anymore, right? You're working with public IP addresses, you're totally visible, and that's what's going to happen. You should have a look at the file varlog auth authentication log, when you're actually running a machine on a public network, and see how many people try to log into your machine like 5 minutes after you launched one in AWS. It's actually quite fun to see. So there's a good reason why we run our stuff only locally here. So yeah, there could be fellow students that try their luck, or the security students in particular. But in principle, you'll be fairly secure, especially if you get your network configuration wrong, something we actually need to deal with ourselves in this case. So, okay. So I'll briefly show you the interface and run you through some of the ideas, and afterwards I'll ask you to actually do it kind of on your own to get a bit of a feel of what's happening there. So here you see OpenStack. So I'm logged in right now. Ensure that your project is IMT 2681H18, so first autumn, so this semester, and then followed by your NTNU username. So you see something like that, generally the overview, compute overview, and that will be all empty. You have circles, you have some sort of quota. For example, I'm allowed to have 3 instances. Wow, 3 instances, so 3 different machines running in there with 3 virtual CPUs. So I can decide how I want to use that. Do you want to use all the 3 virtual CPUs on one instance? Good luck, I don't think that's possible. But let's say you can use 2 of those virtual CPUs on one instance, right? And all the memory of my 6 gig that I have. Or do you want to distribute it fairly, and so on? That's where the kind of the designing comes into place, where you decide, okay, how do you want to distribute your operation? Do you have 2 hosts, one for databases, one for web serving, and they have different properties, or do you want to put it on one host, and things like this? So you see RAM that's available, floating IPs. Okay, what is floating IPs? Does anyone have a glimpse or an idea, or wants to guess, perhaps? You for a change, yeah?
Static public IP address that you've been assigned.
Yeah, cool. Why is that necessary?
Because if you want to host a website, you want to actually have it public.
Okay. Yep. So you're on the right track. Yes. What your comment?
I didn't hear what he said, but a floating IP is just basically an IP that's accessible on this network, the NTNU network. Any interface or instance that you make will exist on your private network,
yeah,
only on Sky High.
Cool. Precisely. So it's an IaaS service, meaning it also includes networking, and that also includes private networking. So you can have an internal network that is internal to your instance here as well, right? To your project, basically, that you can manage. And that's by no means directly connected to NTNU. It could just be close, right? No connection to the internet, perfectly fine, right? But if you want to have connection to the internet, particularly from some or more instances, you want to use floating IPs for that purpose. You had a comment?
Yes. What's really cool about those floating IPs is that you can move those from instance to instance as you wish. If you have, for example, one instance where you're working on a service and another that is running, that's working, and you're experimenting on another one, you can move the IP so that all the users you might have, fake users or otherwise, will only use that IP to access the service.
Yeah. Exactly, right? So it's like basically your customer-facing IP, if you like, and you can quickly, at runtime, associate it or disassociate it from individual instances, as you just said. So really, really powerful, really nice functionality. Cool, yeah. So that's something. Then we have security groups. yeah, does anyone wanna? What is security groups about? Any guesses? Perhaps someone else, not the usual 2 suspects, 3 or so suspects. Good. Okay, that's the hardware class over there. No security groups. Okay, fallback mechanism. Okay, default strategy.
A security group is, as far as I've understood it, a set of rules of, for example, accepted services and ports and stuff like that you can use for one particular type of instance that needs that kind of access, or you can make another one that's more restricted and more open one for another kind of instance.
Yeah. Additional comments from this fraction over here? No? Nah, roughly that? So yeah, it boils down as simple to which ports are you allowed to access on the network or not, right? So what's the traffic packet filtering, basically, your firewall. So one of the key things is, we didn't talk about it much in Linux, because actually you guys, for that reason, it's one of those things you won't need to deal with. It actually has very powerful firewalling built in, right? So to control incoming, outgoing packets and so on, right? All built in the operating system. But the idea here is, let's remove this from the operating system and put it into the platform itself. So we can quickly assign those rules to any possible operating system we're running here, and generically in one click. So we don't need to go log into that system, configure it, log out again, and so on, right? So we assign a security group a set of network traffic rules that we can reuse then quite easily. So volumes is just data volumes that you can additionally attach. Like, think about additional hardware partition you attach to your machine if you need more juice. You can do that at runtime as well, and flexibly re-associate it with different virtual machines. And of course, there are constraints on storage, of course, as well. So that's the kind of facility that's provided by OpenStack out of the box. Quite cool. I mean, it's far less than Amazon has to provide, but it's a solid basis to have a fully running machine, right? So, and if you want to have a bit more, want to play more with this for whatever reason, then you can probably ask Eek and see if you can get a bit richer capacity on your particular instance. But I think for our purposes, we probably get away with this quite well. So, one thing that is very important is to follow the instructions, the initial setup instructions, and I have a link on to this one here on the wiki, but it's important that you choose the initial setup using the web interface. You also see there's an initial setup using the command line, so we can actually do everything from command line as well. So again, it's one of those references to everything is about dealing with APIs ultimately, right? So, but of course for us it's quite handy to do that. So the idea is, after logging in, that's just what we saw right now, you have a set of different menus. So one of them is compute. So here's the overview. You saw that I already seem to have some instances there. If you look at instances, no, it's not timing out. You see precisely that setup. So here's a testing instance that happens to run Ubuntu Server 16. It has an internal IP and one of those floating IPs, so you can actually access it from the outside, as just mentioned before, right? So this is just internal to the network. We'll see it in a second. There's a flavor. Okay. What is flavor? Huh? Sweet, bitter, savory? Anyone? Okay.
It's basically an instance size specifying the number of CPUs and amount of RAM that you use.
That's right.
You might want to use a smaller flavor, for example, for an instance that does one thing and one thing only. For example, load balancing.
Yeah.
Doesn't need much RAM, just needs to forward packets.
Exactly. So when you for example, in this instances window, click on launch instance, some other dialog will pop up, wizard, and it basically just asks you, okay, what's the name for your instance? Test2. So, and a description, availability zone. In this case, only one is Nova. Is this again, as I mentioned, there were those 5 modules, components, and Nova is the one that actually does the computing in our case, and it will ask you to pick an image, and you'll see here, this is the image service glance coming in and saying, okay, what is the functional, what image do you want? What operating system are you keen in running, right? So here seems to be from the ops course, there seems to be a Puppet Learning VM, for example, they've been using. But if you want to, for example, run Windows 10 in its Enterprise Edition, or Windows Server 2016, but of course a vast variety of different Linuxes, being it Ubuntu Server 16, 14, or the latest 18, I think is on there as well. anyway, I saw it at least. So then you can quickly pick those ones and just say, okay, I want to run this image. I just want to create an instance running this particular operating system. And then you are off to the flavors. So and that's something, as you mentioned before, different configuration strategies. So if you see, of course, most of them are constrained by my associated quotas, but there's actually quite some interesting stuff in there. So the highest instance here provided by OpenStack, which is no comparison to AWS, is at least, it is 16 CPUs and 32 gig of RAM, right? So it's quite juicy already for an individual instance. And of course, you can extend it with additional volumes if you need more disk space and the like. I, of course, can't do that right now. I would be limited to something like my tiny instance. But if you talk about flavors, it is kind of a fixed set of configurations, right? So, yes. And then you can basically attach those to your new instance. So I attach the operating system, I attach the flavor right now, and there's some networking. There happens to be a network here. We need to talk about this in a second, a bit more, that I'm attaching it to. Additional network ports. This is basically if you want your machine to have more than one network port on a given network, the internal. It's not something we will use, so you can ignore that. And there's security groups. And they're quite important. They basically tell me the firewall rules I want to apply to a particular machine. And there's a default rule and 2 additional ones. We have a look at this in a second. And one of the other things is to associate key pairs. So every one of you, and that's a kind of a bit of a tedious process. You do it kind of once, but you need to do it. We need to create a key pair which you use to access your instance. So we're using key files, not username and password, to access our instances once they are generated and deployed, simply for security reasons. It's a lot harder to crack a key file than a normal user password. So we're not playing with any of that. You will create a key pair and then download the private key file and use that, for example, using SSH like PuTTY on Windows or SSH in Linux to connect to that instance. So, but of course, to do that, you need to associate the corresponding key pair that you want to choose with that machine, right? So that's something you need to do as well. If you don't pick anything, you can't log into your machine. But it's something you learn very quickly. After your 5th machine, you probably have debugged your way through all the correct and wrong configurations you can do. So the rest doesn't really matter too much. You can customize the machine by script. If you have something you always want to run after the machine has been run for the first time, you can put it in here, not something to deal with. You can have server groups. Quite helpful if you want to do load balancing and you want to put all your web servers in one group and all your database servers in one group and so on and manage them together. That is the way to do it. You do additional scheduling hints. It doesn't really matter too much, metadata and so on. And then once you're done with this, you kind of say something like launch instance, and it will take a bit. And it will say something like this. So it's a cryptic name here. The flavor is associated, will build it and put a particular key pair on it, and then it's already available. So, okay, so I did this, but I'll jump over it and come back to it later again. So that's basically all you need to do to get a new instance running. So this one is now available under the internal network 192.168.0.11. So let's look at the network bit first, because that's the first thing you need to do before you can actually run an individual instance. So So they have this quite helpful overview here of network topology, and that basically highlights exactly what your topology looks like. We have a NTNU internal network. That's the one you are on right now, right? So meaning any instance that's more or less directly connected to this network can, of course, interact. But you also have this private network here, and that's this project internal one, which you will need to create. And that also consists of a gateway or a router, if you like, that distributes IP addresses across the individual hosts. And that's precisely where the networking bit comes in that we talked about last week. So if you don't know what networking is in subnets, yeah, you kind of need to watch the videos again, because that's precisely what you will need to do. You need to set up your private mini network before you can actually do something meaningful. So how does it work? You basically create a new network that needs to have a particular subnet associated with this, right? So you can and that's here where you come up with your subnet. So we talked about network addresses and the prefixes and all that kind of stuff. So you need to come up with a private network which is basically accessible to all your individual instances. and so on. So that's the one of the first thing you want to do. But another thing you actually need to do then is to create actually a gateway which links to the external network. So those are the two components. Specify what the internal network structure is, which subnet particular, and you need to create a router that actually connects to an external network. In our case, the external network is NTNU internal. Yeah, it's like a bit confusing right now. So from your private network, you're connected to NTNU internal, so you can access it from this network. And if you want to access or be connected to this network, you either need to be in NTNU, because it's NTNU internal, or logged in via VPN, right? So that's the key idea that needs to be done here. So once that is all done, you kind of have a mini network, and your topology should roughly look like this, right? So that you have an internal network and your instances need to be connected. That's what you do when you instantiate the individual hosts. That you actually asking him what network you want to connect to. If you recall, that quota is exceeded. I can't do much right now. Yeah, but you may recall that I attach it to some network, and you give that network a name, and that will be enough for that purpose. So in addition to creating a network, so that's the another thing you want to do is to look at security groups, and those are the default rules for network traffic that can be performed. There's a default rule in there which I typically kind of leave unchanged, and the only thing that it does is to allow the virtual host to communicate to the outside, but nothing can communicate with the host itself, right? So you can't really access it, and that's of course intentional. In fact, there's a bit of a modification here because there's access to port 8080, but you get a fresh set of rules basically. So in this default case, the host can, for example, look for updates, but you can't actually access it. So you will need to create either additional rules in your security group, or create a new security group that just serves that purpose. For example, SSH access or something like that. And then you need to specify, okay, what so SSH access manage rules. Yeah, and there's not much happening here, but what you will need to set up is basically that you want to have allow incoming traffic for SSH. Okay, coming back to the TCP IP stack. SSH, which port does it run on?
23.
So
22.
Better. 22 is better. So, okay.
Off by one.
Good, good. So 22 will do. Good. Issue. Which protocol? What transport protocols did we talk about in networking?
TCP and UDP.
Cool. Which one is it?
For SSH.
Yeah.
Well, for secured things, we should go with TCP, I guess.
Okay. Is security the right word in this context?
Reliable.
Reliable, right? So not
Yeah,
security,
reliable.
reliable. Yeah, cool. So because you need to ensure that every keystroke is actually passed to the other machine, because SSH is like a console service, you cannot afford to lose stuff. So it's basically TCP. In fact, it will only listen on the TCP port anyway. So those are the kind of many things you need to know, of course, from the networking aspects perspective. So you want to allow incoming. Ingress means incoming traffic, egress outgoing traffic. To a particular port. You can also specify port ranges, or all ports. Don't do it. Like don't, okay? You can, but don't. So, ideally you specify a specific port, and the rest you don't need to worry about. Basically, you allow access from any remote host, right? So otherwise you would need to specify, or you can specify even the source address. For example, the laptop, the NTNU internal IP address of your laptop could be specified here, so ensure that only you have access. But that one will change every time you reconnect, so don't bother with it. Just let it sit at 0.0.0/0. So anyone from the outside can connect to port 22. But recall, you need to authenticate in SSH, so only the people that have your key file can actually get into your instance. So that's something you would need to set up. And then you have another security group here. So, and again, those security groups are attached to the individual instances. If you have an instance here and you want to change the security group, you just go to the instances selection menu. And here's pretty much everything you can do. And you find something like edit security groups here. So you can do that at runtime, anytime. And you want to, here for example, this instance runs with the default rule, and you want to give SSH access, you just add this particular security group, and now one should be able to actually log into that machine using SSH. So networking again, floating IPs. One of the aspects that was mentioned before that we need to do in order to access from the outside, recall that the machines have network access, but only to the internal network, and they can access the internet via the internal network, but they're actually hidden by the gateway here, right? So what would be the only logical way if you run your own home network to give access to your internal machine from the outside? How could you do it in your home network?
Well, you have a router.
Yeah, and then you could
the router has an IP that's the default gate for the other host machines that are connected to the router.
Yeah, and if you want to allow, for example, incoming traffic into your home network, what can you do to do that?
Well, the router assigns IPs to the host machines on your local network, and it has the NAT table, so it will distribute those. But to help it, maybe you can assign ports to each host machine or something. So the filtering.
What's the formal term for what you're describing there?
Is port forwarding?
Port forwarding, right? So you can basically say, hey, every time I get a request on port 80 on the gateway, redirect it to machine number 1. Go away. To machine number 1, right? So, and everything I get on 22, go to machine number 2. So it'd be one way. So the way around is here in this particular context is to directly associate or map. And that's the neat thing you can do in IaaS environments. You can map virtually different IP addresses at any time. Map a floating IP address directly to the host. So the host will then get a floating IP. So evidently I did this for some instances here. And that's what you can do basically in your instance window as well. When it's running, you just say associate floating IP, and it will get another IP from the NTNU pool of floating IP addresses. You just say, I want a new one from NTNU internal. You can give it a name or not, doesn't matter. You can use up some, again, quotas limiting. And it says, okay, here, I got the IP 212.137.160. And you can say, well, I want to connect this to this network interface card on this particular host, and from then on this machine should be accessible using this particular IP address. So that's basically the whole idea around it. Let's see if that actually works. Using PuTTY here. So for now, one comment. If you are using so since you're using key files to actually log in, right? So you generally don't have a username and password combination, of course. So you need to know the operating system specific default username for using key files for login. So in this case, it's associated with the user Ubuntu in those stock images. That's something that someone specifies who creates the stock images on the service needs to kind of tell you. So for Ubuntu images, it's always the user Ubuntu. And then if you say Ubuntu at IP address, you should be able to connect. The reason here is I have the key pair already registered on my machine, so it's quite straightforward. So now I have direct access and can do anything on this particular machine, including reboot, installing software, running Go, at least run the first command you probably should do is run your updates and your upgrades, because usually those stock images are a bit behind in terms of upgrades because they need to be maintained actively, which they usually, well, to some extent only. So you see there's considerable stuff to upgrade. Something you want to do first would be 115 megabytes, which I'm of course not doing right now. But this just to give you a feel of how that is actually gonna work and happening. So I mentioned key pairs. So that's the most important bit regarding networking. So you need to create your routers, your networks, and then assess your topology, that it actually looks roughly like this one here. Of course, your number of hosts may vary, but you just need to ensure that everything is connected together. Volumes, don't worry about those ones. They are just about data volumes. That's just additional data, like think about it like additional hard drives you attach to your machine. But by default, your instance already has a hard drive. So the volumes are not counted against that one. That's an additional concept, block storage. We're not dealing with this. But something you need to do is to create key pairs. And that's basically how you do it. You say create key pair, give it a name, and then it will ask you to download it, and you get something like a PEM file in this particular case, right? So that's the private key file you can use. You can directly use it in Linux using the SSH command. In Windows, you will need to convert it into a PPK file that can be used with PuTTY, with this tool I just showed you here. Are you guys comfortable with PuTTY? Did you hear about this before? Who didn't hear about PuTTY? Be daring, just tell me. No? Yeah, everyone kind of heard a bit about PuTTY or not? No? So it's basically the Windows default client for SSH. SSH is this, what I'm doing here right now. It's kind of a terminal protocol, terminal access protocol, which is secure. That's secure shell service. And that's the Windows way of dealing with this. So I put a link to a tutorial of how to actually use it. Not so much how to use it, but how to set it up in the wiki as well. But basically what you will see when you start it, PuTTY is something like this. You need to enter a username and the host name, so usually in the format Ubuntu, here in this case, @ and then it's the IP address, and then the port of choice that you would need to connect to. And then under, where was it, authentication, you need to specify the key file we just downloaded basically. But we need to convert it first using another tool. Again, the details of that one are described in the wiki, so it's no point really me running through that here right now. It's probably faster if you just follow that instruction. In Linux, it's very direct and easy and straightforward. The nice part is you do this once. Because once you have set up your key file on your client side, you can reuse it across, well, you shouldn't, but for development purposes, it's fine. You can reuse it across multiple instances. You just assign a key pair to a particular instance you're creating, and off you go. So for me, it's very fast creating yet another instance and immediately connect to it. Okay.
Is that fair?
Yeah.
Can you give a key file so that the SSH only has like a regular user, or will you always get root access when you SSH?
It has by default regular access, but sudo permissions. So what you can do, I'm always hesitant telling that people, but so of course you're logging in with Ubuntu @ right? So then you have Ubuntu permissions, which is regular user. You can use sudo, but if you want to desperately be root, then you can do a sudo su, right? So then you have a root access. Can just showcase that briefly. You have full control basically. I'm not doing the updates right now. So of course, right now I'm a regular user. You see it because of the dollar sign. But if you say sudo, you can do anything you like. For example, watch the network configuration. But if you are want to be really super user, you can just say sudo su, and it will you will see based on the hash symbol after the path that you're now super user. You're root now, right? You can do anything. You have full control. But by default, you shouldn't have anyway under Linux, right? But again, there's no limitations as to what you can do on the machine. It's not like somewhere else is monitoring you and giving you limited user rights. That's your instance. In fact, in worst case, just blow it away and you'll be fine, right? So in case things go sideways. On that note, before do you want to talk about snapshotting?
No, I was going to talk about superuser and sudo.
Can we? Yeah, okay, please.
Yeah, this may be redundant, but as opposed to Windows, where the default account is the administrator account, your default account in Linux is not the root account. It just has sudo permission, which means it can do what the root account can do.
Yeah.
Using the sudo command.
Yeah.
Using sudo su logs you into the root user, and you really almost never have a need to do this.
That's correct.
In one terminal window, if you type sudo once and type in the password, you can type sudo as many times as you want, and you'll usually not have to enter the password again.
That's why my prefix there. I usually don't want to share that information, so because usually people just log in sudo su and do everything there. But it will screw them over in practice here, because the profile usually for development, Go and the like, is usually set up for the regular user. So eventually I figure that out and exit again into normal user anyway. But it's an absolute valid point. You shouldn't work as super user if you don't need to, because if your program runs with your permission set and has some security flaw, it has your permissions, meaning root permissions, not optimal. So one thing I wanted to mention before I leave you in peace is you can actually create runtime screenshot. You probably can create screenshots as well. Let's assume that, but snapshots. So you're configuring your machine. You say, okay, I like this configuration right now, but I want to do X. You can just say create snapshot, give it a name, and store that, right? Test2. So, and then in case things go sideways, you can always go back to that snapshot. So it's really, really nice. So you can't ever get your configuration wrong in your system because you just create a snapshot first. It's there you go, test snap. And this snapshot can be launched afterwards. It's an own machine in its own right if you want. You can launch one or more instances from that snapshot back. So it's a very cheap way of replicating machines. So you set up, one machine, one Go server basically, get it all set up, then create a snapshot and create multiple new instances from that one. Very fast of replicating the entire set of networks, machines, right? So it's quite neat feature as well. So what I would like you to do is, of course, explore that a bit and follow this instruction here. So it basically has everything I just talked about. And if you really forgot everything about networking, you can just blindly follow that guide and you'll be fine because those values will work, test it, of course. And create, your first instance as well of Ubuntu 18 or something like this, and just log in and see that you get access to it, ideally. For the more experienced amongst you, I would encourage you to deploy, for example, your Go app on that one, right? So, few things to bear in mind as a checklist, of course. Create your key pair and keep it. Don't recreate one every time you make an instance, so that makes the development way, way faster. One-time effort. Also, security groups, create them early, so you want to know which ports are available. Which ports are we generally using on machines for our development purposes? 80? What was 80 about? Cool, what else? 22 for SSH, what else? 8080 as a kind of debug web service port. So I generally set up another security group that covers all those ports. So you're done with the networking bit as well. Well, not quite. And then, of course, you need to configure your individual instances. Before you do all that, follow this guide and do the network setup first. You do that once as well, then you're done with this forever as well. So it's a bit of investment, but once you have done it, things should work out of the box. Here's again, that's how your network should look like, and so on. So it's a fairly good guide, fairly straightforward, and a lot of pictures in there. It's all linked from the wiki. So if you want and you're more advanced, deploy your own Go project on there. You of course need to install the Go environment, but that shouldn't challenge some of you then. Good. Cool. Thank you very much for your attention.